Okay, Wildcats, so we'll look at Monday, February 4th, square root transformations on page 42. If you would, update your table of contents. Okay, now your table of contents are updated. Let's take a look at the notes. All right, square root transformations on page 42. F of x equals negative a square root of negative bx minus h plus k. The negative in front of the a reflects over the x-axis. When a is greater than 1, it's a vertical stretch. When a is greater than 0 but less than 1, it's a vertical compression. When the negative is in front of the b inside of the square root, it reflects over the y-axis. When b is greater than 0 but less than 1, it's a horizontal stretch. When b is greater than 1, it's a horizontal compression. When it's plus h, it translates left. When it's minus h, it translates right. When it's plus k, it translates up. When it's minus k, it translates down. If you would, update your notes. All right, now your notes are updated. Let's take a look at the examples. All right, graph the square root function, describe the transformation, and then state the domain and range. Okay, so to graph the square root, we're going to make a table. Okay, so let's start with x is 0. Okay, when x is 0, the square root of 0 equals 0. When x is 1, the square root of 1 is 1. When x is 4, the square root of 4 is 2. And when x is 9, the square root of 9 is 3. Notice that I picked x values that I could take the square root of. Okay, so now we graph those points 0, 0, 1, 1, 4, 1, 2, 3, 4, 2, and then 9, 1, 2, 3. Now, there are no transformations because that's the parent function. Now, the domain starts at 0, so it's bracket 0 to infinity. And the range starts at 0, and it's bracket 0 to infinity. All right, now let's take a look at example 2. Now, for example 2, we're going to use our calculator. So if you don't have a calculator at this point, you can use Desmos, or you can wait till you're in class with the calculator. Now, I'm going to adjust the lighting a little bit. Try to adjust it so you can see it. All right, so I'm going to go to On, New Document, no, Add Graph. And I'm going to graph negative 3, control, square root, x minus 1, click to the right, plus 2. Let me see if I can try to adjust that's too light, that's maybe too dark. We'll make it work, okay? Now we're going to press Control T. Now you want to pick an x value all the way to the far left of the graph, so negative 10, when x is negative 10. Now you can see that it is undefined. Okay, and maybe if I adjust the lighting here, let me see. I guess I don't know what to tell you. We'll just have to make do. All right. Now, you'll see that it's undefined, 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 defined. So when x is 1, we can graph that point. So the first point is 1, 2. Okay. So let's make a table here of our values. So 1, 2, 2, negative 1. So it's right 2, down 1. I'm not going to use that point because it's a decimal. I'm not going to use that point because it's decimal. 5, negative 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, not going to use 6, not going to use 7, not going to use 8, 9, 10, negative 7. So 10, negative 1, 2, 3, 4, 5, 6, 7. And there's your graph. Okay. All right. So transformations, let's look from left to right. So the first one, it reflects the x-axis. Next one, the 3 is a vertical stretch of 3. And then the next one is its right 1 unit and up 2 units. Now domain is bracket. It starts here at +1, goes to infinity. Here it's reflected, so it actually starts from -infinity and it goes to, it looks like +2. Sorry, I got a little bright there. All right, now let's move on. I'm gonna give you a few seconds to finish up example 1 and 2. Also turned off the light and adjust this light. See if we could adjust the camera. One of these days I'm gonna get the camera and lighting all perfect and good, but there we go. All right, but enough of your time has been wasted listening to me, so let's move on to example 3. All right, use the description to write the square root function function g based on the parent function f of x equals square root of x. Example 3. F is reflected across the x-axis, compressed vertically by a factor of 1/5, and translated down 4 units. So g of x, now if it's reflected across the x-axis, it is negative in front. The compression 1/5 is in front. Square root of x, and down would be -4. Okay. All right, example 4. Reflect f across the y-axis and translate 3 units up. So g of x would equal the square root of, the negative is inside the square root because it reflects the y-axis, and translates up would be +3. Okay, example 5. F is translated left 5 units and 4 units down. So g of x equals left, remember it's opposite, so you think negative, but it's actually x plus 5. And then down 4 units would be -4. Okay, finish up examples 3, 4, and 5. All right, let's take a look at example 6 and 7. Okay, so again, we're going to use our calculator to graph that. So we're going to go to on, new document, no, add graph. Now, we delete the equal sign, we pick our inequality, and then control square root x plus 4. And then I'm going to go to menu, view, grid, line grid. And here we're looking for points. And let's just go ahead and make the table. Here are the points that we can use. Okay. Now, it looks like I can use this point right here. So -1, 2, 3, 4. So -4, 0. Now I'm going to move my cursor over the line just so I can see that it's going to be a dashed line. That point looks like we can use it. So -1, 2, 3, 1. Not a good point, not a good point. That looks like a good point. So 0, +2. Not a good point, not a good point, not a good point. That looks like a good point. So that's 1, 2, 3, 4, 5. 1, 2, 3. So 5, 3. And doesn't look like any of the other points are good. So now let's graph. So -1, 2, 3, 4, 0. -3, 1. 0, 2. And 1, 2, 3, 4, 5. 1, 2, 3. Now we know it's a dashed line. because we see it in the calculator, and we also know because there's no line underneath. Now, you notice that it didn't shade past this line because you can't have a number under squares that's negative. And so negative 5 plus 4 equals the square root of negative 1. So that point wouldn't be valid, so we can't shade to the left of that, of 4, or negative 4, so we know our shading is here. Okay, all right, now let's finish up with example 7. So now another way to do it is, see, if I press Control T in this format, it says there are no functions available to display. So we can't actually use the table when we use inequality. So another way we can do example 7 is this way. So on, new document, no, add graph. We're just going to ignore the inequality for the moment. So negative control square root x plus 3. Now I'm going to press Control T to get the table. So we'll get our table here. Okay, we're going to start when x is negative 10 because that's how far the table goes. Now you'll see that it's error, but it's 0, 3 is a good point. 1, 2, that doesn't work. 4, 1, 9, 0, and I believe that's as most points we're going to get. So let's graph those points first. So 0, 3, 1, 2, 3, 1, 2, 4, 1, 2, 3, 4, 1, and then 9, 0. Now, to understand if the line is solid or dashed, what I'm going to do now is press Control T, Tab. I'm going to delete this and the equal sign. Now I'm going to graph with the inequality now that I have the points. And negative control square root of x plus 3. So now I see the shading, and I can move the cursor over the line, and I see that it's solid. So solid line. It's a solid line because there's a line underneath the inequality. And here we shade. All right, so if you would, finish up your example, start working on your assignment, and have a wonderful Wildcat